in this session on definite integration, I'll explain step by step. No, better to say I'll devise step by step all the concepts you need for WBJEE mathematics. I think after this session you can approach any sum on definite integration, because already one session on Leibniz rule is taken. Hope you have understood. So this class starts with the revision of concept of definite integration as the limit of sum. This is meaning of definite integration. Why you will do definite integration? Based on that. Meaning of definite integration, that a to b fx dx equal to integrand b fx. I mean that function has integrand fx. Or if you differentiate fx, you will be getting fx back. Then this will give you fb minus f. Okay? This you know. And geometrical meaning is what? This will represent the area bounded by the curve between, this is the curve, say y equal to fx. This end has abscissa A, this one B. So if this is y equal to fx, this is equal to area bounded by the curve y equal to fx between A and B. Area between A and B. But this area you have calculated based on this concept, that a to b fx dx, this is limit of sum, limit h tending to 0, h sigma r equal to 1 to n f of a plus rh, and you know the value of that r. nh equal to what? nh equal to b minus a. So if you replace h by b minus a by n, then this is going to be limit. This is just to remind you. This is going to be b minus a by n, r equal to 1 to n, f of a plus r into b minus a by n. Normally, when we solve problems, we replace a by 0, b by 1. This we write as n tending to infinity 1 by n sigma r equal to 1 to n f of r by n. So this you can say application of definite integration to solve the infinite series. If a series is given which is infinite by nature, then solution, summation of the series can be determined easily by the use of definite integration. This we'll find. Alright, just take one example for that you remember better. Suppose the infinite series is given this form. Just one example I am taking from here so that you will remember. You have to evaluate this thing. N tending to infinity 1 by n tan pi by 4n. As you all have appeared class 12 exam, so I think this solution you will understand. Because you have done the concept before, you are just revising here. This tan of n pi by 4. So this will be n tending to infinity 1 by n, put a sigma sign over there. See, pi multiple is being changed, 1, 2, 3, so you write sigma r equal to 1 to n tan r pi by 4n. Alright? So here, when you have written fx dx equal to this, all you are getting this integrand back from here. You can see that this, by putting a0 and b1, the integrand changed to 0 to 1 fx. Okay? So you don't have to pay attention over there. It will remain 0 to 1. Only r by n will be changed to x. Like for this one. Remaining terms, same here. So this you can write 0 to 1 fx. What is fx here? This is tan of, you are replacing r by n by x. By x by 4 and then dx. Hope you have understood. The integration of this thing, that is tan x is log sec x. So you will write log sec pi x by 4, that divided by pi by 4. During integration you divide. Now put upper limit and lower limit. So this is going to be 4 by pi log of sec pi by 4 log of sec 0. 4 by pi log sec pi by 4 is what? Sec pi by 4 root 2. So this is root 2. Root 2 is, log root 2 is half log 2. So it is 2 by pi log 2. This is the answer. This infinite series can be solved with the help of definite integration very fast. Now, you need to revise the concept of some properties of definite integration. I'll assume that all of you remember how definite integration you have to solve by substitution, all these things. That I am not going to revise. I am just going to write important properties of definite integration. Like if we start with this, that a to b fx dx, a to b fx dx, this will be greater than or equal to 0 in a to b if fx greater than or equal to 0. Okay? Number 2, if fx is positive, a to b fx dx has to be positive for all points in AB. For all x belongs to AB. This you haven't done before when you have done those 7 standard properties. Out of those 7 standard properties, what is required, that I will definitely tell you. Second property is, let fx less than or equal to gx on AB. Then integration of a to b. I have seen many years WBJEE, they are asking questions based on this. You can use this thing properly. Directly. A to b dx. Third property, if one function less than the other, then the integration of that in the same interval will be less than the integration of the same function. Okay? And another very interesting and important property, mod of a to b fx dx less than or equal to a to b mod of fx dx. Then number 4, this you have done before, I just remind you. A to b fx dx, because many sums will be based on this concept. A to c fx dx plus c to b fx dx. As definite integration is sum only, that's why if a point c lies in between, then it is valid. Even c is outside, then also it will be valid. Remember. Okay, this property you have studied before. And next one is, you have done many sums based on it. I just remind you, 0 to a fx dx is f of a minus x dx. Sometimes they ask questions based on this also. A to b fx dx will be a to b f of a plus b minus x dx. Okay. Now properties on even function and odd function. Minus a to a fx dx will be 2 into 0 to a fx dx if fx is even. Even means what? F of minus x equal to f of x. And this will be completely equal to 0 if it is odd. There is f of minus x equal to minus f. Okay? That definite integration value will be 0. Now, one property is there on the smallest and greatest value in the interval. WBJEE, they have not asked many questions based on this, but sometimes WBJEE MCQ solution on inequalities can be done quickly with the help of this. For this function fx, for y equal to fx, let m and m be the lower and upper bound, or you can say lower and bound, or you can say this, or minimum and maximum values of fx. We will find sums based on it. I will show you in 2020 or 21. Question has come based on it. Lower and upper bound or minimum and maximum values of fx, then m into b minus a to b fx dx less than or equal to capital M into b minus a. The greatest value into b minus a. Okay? And then on periodic function. Periodic function, you know, the function whose graph repeats in a fixed interval. Fx is periodic if f of x plus t equal to f of x. Then it will be periodic function. Sin x, cos x, all are periods. Sin x has fundamental period 2x. There is many periods. T may be 2 pi, 4 pi, 6 pi. Why? Because f of 2 pi plus x equal to f. Sin 2 pi plus x is sin x. That's why. Even f of 0 plus x. But 0 cannot be taken as period. Period is a non-zero positive quantity here. Okay? So T will be, the fundamental period will be 2 pi. Okay? If there is a periodic function with period t, let fx be a periodic function with period t, then a plus nt to b plus nt fx dx will be simply a to b fx dx. Okay. This n must be an integer. N is an integer. It may be another one. In particular, you can write this. In particular, 0 to nt fx dx equal to n into 0 to t fx dx. Here, understood? Now, how you solve sums where lower limit or upper limit is infinite? That also you haven't done before. When you are solving this one, a to infinity fx dx, you better solve it this manner. Limit b tending to infinity a to b fx dx. Okay, that limit calculation will not be difficult for you. You can use L'Hopital rule also over there. Similarly, if there is lower limit, say infinity to b fx dx, then you can write limit a tending to infinity a to b fx. Okay. Previously, the upper limit tending to infinity. Now the lower limit is tending to infinity. So what we will do, simply we will calculate this part, then apply the limit over there. Now problem may be there of this kind also. Suppose it is minus infinity to infinity fx dx. Okay? Then you will be writing this one as one intermediate value be a minus infinity to a fx dx plus a to infinity fx dx. Alright? Use this one. Then solution will be like before. This one will solve. How to solve? That limit extending to infinity x to a fx dx, and this one y tending to infinity a to y fx dx. Got the point? If you want to solve it, then it will be limit x tending to minus infinity x to a fx dx plus limit y tending to infinity. Okay? So this you need to remember. And another thing is reduction formula. Question they are asking on reduction formula also nowadays. But simple things I have observed. What is that? That 0 to pi by 2 sine to the power nx dx, 0 to pi by 2 cos to the power nx dx, this is going to be n minus 1 by n, remember the result, n minus 3 by n minus 2 into half into pi by 2 if n is even. This thing will be changed, the last one, this will remain the same. It will end at 2 by 3. 4 by 5 into 2 by 3 if n is odd. Okay? If n is odd, then this is true. Proof can be done, and that concept will help you to solve sums related to it. That's why I'll be giving you proof of one part of it. So let us start with this thing. Let Jn equal to, this trick can help you to solve on reduction formula of other functions. I have seen it in 1 year, that's why it is better to practice, cannot skip. So let Jn equal to this. This you write in the form 0 to pi by 2 sine to the power n minus 1x into sin x dx. Okay? We'll be taking this one as second function and this one as first function. Obviously, we'll do by parts. So, no, just opposite. You take this one as first and this one as second, because its integration can be done easily. Okay? So this one first function minus cos x 0 to pi by 2, this minus n minus 1 n minus 2x cos x, and then minus cos x will come there. Okay? And 0 to pi by 2. The first part value is 0 because cos pi by 2 is 0 and sin 0 is 0. This minus minus will be plus, and this is changed to 0 to pi by 2 n minus 1 cos square x is what? 1 minus sin square x. You'll get the benefit of remembering the formula here. I can assure you. Sin to the power n minus 2x, okay, minus n minus 1 sin to the power n minus 2 into sin square will be sin to the power nx. Do you see something over there? This chain we have started with, we got it back. So chain is now going to be n minus 1, this we can denote by jn minus 2, n minus 1, jn. Transfer it on the left side. 1 plus n minus 1 jn, n minus 1 jn minus 2. So jn is what? N minus 1 by n, j n minus 2. This is actually the reduction formula. You have expressed, you have reduced jn in terms of jn minus 2. That's why it is called reduction formula. Now replace n by n minus 2. So jn minus 2 will be what? J n minus 4. Again, you replace here or here. This is number 1. Number 2, replace. I need jn minus 4. In 1. What do you observe? N minus 5 by j n minus 6. Isn't it? Number 3. And it continues this manner. Okay? It continues this way. I'll stop it at J4 because J2, no, J6. If we apply it here, stop it at J4. J4 is what? 3 by 4 J2. This you don't find with the help of this. J2 means what? Sine square x dx. Okay? This you can write 3 by 8 2 sine square x dx. Okay? Understood? Now 2 sine square x is what? 1 minus cos 2x. Oh, sorry. This you have to integrate, no? 0 to pi by 2, 1 minus cos 2x dx. Okay? So this will be 3 by 8, 1 sine 2x by 2, 0 to, no, sorry, x, pi by 2. So this is changed to 3 pi by 16 by taking n even. If n odd, then where does it stop? For n even we have done it. If you want to use the recurrence relation, let me write it here. Jn is what? N minus 3 by n minus 2, jn minus 4. Jn minus 4 is what? Sorry, jn minus 2. Wait a minute. This you write n minus 1 by n, jn minus 2. Jn minus 2 is here. It continues this manner. Like this. This will stop at J1 if n is odd. J1 means what? Just 0 to pi by 2 sin x dx. You started with sine. So this is minus cos x 0 to pi by 2. So the value will be First pi by 2 0, 1. Okay. So for odd it will stop here, for even it will stop at J2. Okay. It will stop at J2. J2 value is which part? 3 by 4 was common there. So J2 value, if we want to know separately, this is pi by 4. Okay, just if you put it there, if pi by 2 is, you will be getting this. And for in odd, you will be getting this. Okay, so 0 to pi by 2 sine to the power nx, by property it will be changed to cos to the power nx. For n even, it will stop at pi by 2, half pi by 2. And if n is odd, then it will stop at 2 by 2. Keep this thing in your mind and use the result directly. If they have given say sine to the power 10x, no one can solve in this world 0 to pi by 2 sine to the power 10x without using this. If you putting n equal to 10 over there, so long it continues, you write the value. Got the point? So derivation method I told you, and result. This result is very important. You must remember. Okay. Now let us see what kind of problem can be asked here on definite integration property. Let me choose a few sums which is not very difficult, where those properties are in use. The first sum I am asking here, minus 1 to 1 modulo x square plus log. So this will help you to solve two integrations actually. That's why I have chosen this sum. Minus 1 to 1 modulo x square. Okay. And log 2 plus x by 2 minus x. You have to show that which option is correct. This is greatest integer function. Minus 1, 1 and 0. Which one is correct? Doing which option correct, I will show you. Before that, for solving modulo x square, that GIF, I hope you all remember the graph, because in WBJEE GIF function sums, I have seen most of the sums just done by using definite integration as area. You can use half base into altitude or length into breadth also here if you know the diagram. Diagram I hope all of you remember. Still 1. Then it is still 2. Till 3. This is till minus 1. This part minus 2. Hope you all remember. And this part for minus step function. That's it. Go step by step. To solve first part. How will you do it? Modulo x square dx. You just observe that in this interval, in x greater than minus 1 less than 1, equal to it. What will happen? X square has maximum value 1, x square has minimum value 0. Isn't it? Don't put greater than 1 less than 1. That's funny. X greater than minus 1 less than 1. So x square will be, isn't it? So in this interval, modulo x square will be what? No integral part is there. So this thing will be 0 in which interval? Minus 1 to 1. Okay. And what about the second part? The I1? I2 is what? Whenever log function is there in definite integration, no, you'll go for checking whether it is odd or even. Okay? Many sums, this one only here. Log of 2 minus x by 2 plus x. It's nothing but so this is minus f. So I2 integrand is what? Minus 1 to 1 this thing. We have taken fx equal to this thing. We have proved fx odd. So result of I2 will be here what? So finally this is 0, this is 0, and this is correct. Isn't it? As I am doing modulo part, let me solve another one on modulo. This is say 0 to 1.8 modulo x squared dx. We have to evaluate. How to do it? Can we make a substitution for this? Yes. What substitution? Let x square equal to t. So x is root t, dx is 1 by 2 root t dt. Alright? Now put it there. So I equal to what? You change the limit also. Isn't it? 0 to, when x 0, t is 0. When x 1.8, then this is going to be 1.8 squared. 1.8 squared, 3.244. Isn't it? Just put 3.244. Then this will be changed to what? Modulo t dt by 2 root t. Please take care of this part. Hope you have understood. Okay. You have understood this part, modulo t by 2 root 2. Now, since modulo function is involved, we will be doing it by splitting into intervals. 0 to 1 modulo t dt by 2 root t plus 1 to 2 t dt by 2 root t plus 2 to t. Then finally t to 3.24 modulo t by 2 root t. Alright? So 0 to 1, this part is 0 because the greatest integer is 0 here. This part, modulo t will be what? 1. The maximum value 1 here, the maximum integer 1 dt by 2 root t. Here maximum value is what? This plus here maximum value is 3. 3 by 2 root 3. You solve step by step all these things, then it will be done. Isn't it? This thing is what? 3 to the power minus half plus 1 by minus half plus 1, isn't it? So this will be root 3, 1 to 2. This one is what? 2 getting cancelled over there. Again this way, 3 to the power minus half by half plus, this time 2 will be there, 2 root 3. Previously it got cancelled, it will be 2 to 3. You understand? I've just integrated it. In all, 3 to the power minus half dt. Minus half plus 1 by, so it is 2. I'm just putting there simply. This will be what? 3 into 2 root. Again, the same manner. This time 3 to 0.24. Okay, now put it there. Root 2 minus 1. 6 into root 3.24 is what? 1.8 minus root 3 approximately 1.73, or keep it root. Just simplify it. So this technique of definite integration where modulo involved have understood. I'm just taking another one where odd function, even function concept is involved. Suppose this is a mod function. I equal to minus 2 to 2, 1 minus x4 dx. This equal to 6. Part A, 8, 12 and 21. Which one correct? No need to split into intervals. Just use property here. You just, if you take fx equal to 1 minus x4, f of minus x is what? This is 1 minus x to the power 4. So f of minus x is fx. So how do you start? I equal to definite property 2 into 0 to a is 2 also. Mod 1 minus x4 dx. Here. Now in the interval 0 to 1, mod 1 minus x4 positive. If you write this way, 1 minus x4 1 plus x to 1 plus x. If you want to split the function, you draw a sign scheme. You don't have to think about x square plus 1. This is always positive. Isn't it? Minus 1 and here it is 1. So this will be negative, positive, and this will be negative. Because minus sign is there before. So this function, if you split, 0 is in between, no? You write 2 into 1 minus x4 dx plus, you have to remove the mod sign, no? Simple sums and mod you have done in board exam. This will be 2 into, if you want to remove whole 1 minus x4 in 0 to 1 is positive. So you just write and whole 1 minus x4 is negative over there. If it is from 1 to 2. So minus 1 to 2 Got this? Just integrate and put the limits. Yes, I have not given any option, so you do and get this answer. Not wasting time here. You should check. Now, let us go for another one, which is asked in many exams before. I just remind you here, like let K belongs to N. Let K belongs to N, then sin 2kx and just giving by sin x by trigonometry by trigo, this you know 2 into cos x plus cos 3x. If you don't know, you should check cross multiplying and simplifying. Just writing this series. The important sum. If you remember the series, you will be fine. Okay. This thing can be written this. Therefore, let I equal to, for the value of, by knowing this, I have given you whatever you need, the value of 0 to pi by 2 sin 2kx cos x dx is what? Minus pi by 2, 0, pi by 2 and pi. Just think once how to do, then I'll help you. Just think once. It's a big one, no doubt, but you can do it. Just use the series over there. Okay? Periodic function property probably you don't need. No, periodic function property doesn't here. All the sums you don't need. If you remember this series, and this sum or cos 2kx by cos x or cos 2kx by sin x is there, use the series directly. If you split this coming cos x by sin x, so this I will be changed to 0 to pi by 2, 2 into cos x cos 3x cos 2k minus 1x into cos x dx. Can you use property? Ask yourself. No. This is just multiplication by cos x over there. 2 cos square x is 1 plus cos 2x. This will be what? 2 cos 3x cos x cos a plus b plus cos a minus b. Isn't it? And the last one, cos 2kx plus k minus 2k. Alright? So this implies if you integrate, it's going to be x plus sin 2x by 2. Okay, this one also sin 2x by 2 into 2, and this is cos 4x sin 4x. Oh, another sin 4x will come. Just multiply by 2. Like this. We need not consider it because the limit is 0 to pi by 2. All those terms get cancelled. The value will be pi by 2. Right? Hope you have understood. Property was not required for this. But the sum I am going to ask here, you need property. I am asking simple sum only. I equal to pi by 3 to 2 pi by 3 x by 1 plus sin x dx. Which property to be used? You will always think first. Can be used maximum. That is check and then go for the sum. Okay? Which property? Odd function, even function will not work here. Okay? Then A to B Euler property. If odd function, even function is there, not there, just one property is there, A to B fx dx. Many sums in WBJEE have seen past year's paper, they are asking on this. Hope this property will help, because this I equal to will be changed to pi by 3 to 2 pi by 3. Sum is pi minus x by sin pi minus x is sin x dx. Or I equal to this. Therefore, I plus I will be what? Pi by, because the rest get cancelled. So I will be what? Pi you take out. Pi by 3 to 2 pi by 3. This you can multiply by 1 minus sin x pi cos square x dx. Then this will be changed to pi by 2. X square x is tan x. Tan x sec x is sec x 2 pi by 3. Now put the upper limit and lower limit. Tan 2 pi by 3 is tan pi minus second quadrant minus 2 3. This is also in second quadrant. Sec 2 pi by 3 will be minus, that is 2. Then minus tan pi by 3. Root 3 minus sec pi by 3. Sec pi by 3 is here. So this is going to be pi by 2 into 4 minus 2 root 3. This was just a reminder for use of the property. Okay. Now we dare to solve all the sums. Past year's papers, like first 5 years paper at least, so that you will be very confident over there. Okay.